In this example, we're going to be finding the derivative using limits, but two different ways. Using this definition of the derivative, this limit, and then using this one. And we'll see that we get the same answer no matter how we do it. So for the first one, f of a is f prime of a, where a is equal to 1, is going to be the limit as x goes to 1 of f of x, which is just x squared plus 2x minus 1, minus f of a. So same thing, but subbing in 1 for x. So this is 1 squared plus 2 times 1 minus 1. And all of this is divided by x minus 1. Well, this is equal to the limit as x goes to 1 of x squared plus 2x minus 1. Now, this whole thing is going to simplify to 1 plus 2 minus 1, or just a 2. This is going to be minus 2 all over x minus 1. That's equal to the limit as x goes to 1 of x squared, left the x out back here, x squared plus 2x minus 3 over x minus 1. Now that numerator is going to factor into x minus 1 and x plus 3, which you can verify by just FOILing it out. Now at this point, the x minus 1 will cancel with the x minus 1, and we're just left with the limit as x goes to 1 of x plus 3. And so just directly substituting in and letting x go to 1 will give us that f prime of 1 is equal to 4. Now, using the other definition of a limit, this is the limit as h goes to 0. And now what I want to do is everywhere there is an x in my original function, I'm going to substitute that with a plus h, where in this case, a is equal to 1 because that's the that's what we're told to do in the instructions. So I have the limit as h goes to 0 of 1 plus h quantity squared plus 2 times 1 plus h minus 1 minus, and now I'm doing f of 1. But we know what f of 1 is. We evaluated it before up here. That's just going to be 2. All right, so this whole thing is divided by h. So this will be equal to the limit as h goes to 0. And then if we multiply this out, we'll get 1 plus 2h plus h squared plus 2 plus 2h minus 3 all over h. And so simplifying, we'll have the limit as h goes to 0 of 1. Well, look at this. I have a 1 and a 2. That will add up to 3, but then I have a minus 3. So these things will all subtract off, and they won't be there anymore. So what will be left will be 2 times h plus h squared plus 2h all over h. And now, the h in the denominator will cancel. So that one goes away, that one goes away, and here I have h squared, so one of them goes away and just leaves h. So this will equal the limit as h goes to 0 of 2 plus h plus 2. And now let h go to 0, and I'm just left with 2 plus 2, which equals 4. And so you can see we get the same answer, that the derivative f prime of 1 is equal to 4. no matter which way we do it, we get the same answer.